I'm assuming. Others are sort of being introduced to it at Unitec. There were 3 columns that you require information for. The first one is what I call the running chainage. That's what I call it. I think it's just called distance or something like that. Has anyone got that spreadsheet open? It's on Moodle. Anyway, it's a running distance as you're going down the road or across the platform. So the distance will be sort of something like 0 for a start, which will be this one. And then the next distance, which you measure on CAD, which might only be, say, 1.5 metres. This one here, 1.5. This one here, you might measure that at 2.5. So the running total becomes 3. 3? 4. Yeah. 4. Yep. Well. And then so on. Okay. So a lot of students say, well, you know, what is that distance? That is whatever you want to make it. So that'll be 6, and so on. You need to fill that, you need to put that data in, you need to put the cut and the fill in. And then lastly, the difference each time. So these ones have to go in there. Now the first column, you'll notice is 0. So the cut and the fill there will also be 0. But the difference, DIFF, between that and that isn't recorded until the next one, which will be 1.5. Then the next one will be 2.5, and the next one will be 2. All right? You need to fill in these. So the big question on your assignment is, how do we fill that in? Well, we have to draw a series of little, what I call stick diagrams. I don't require an HAD, the cut, the fill, the foundation, the pipe underneath, all those other things that we want on the cross section. No, I just want these lines, and the reason for the lines is I want you to draw on top of this with a P line and come up with an area. That area might be, I don't know, maybe 0.5 meters squared, and this area up here might be 0.25 meters squared. So where does that go? That's your fill, that's your cut. So it'll go under the column. I'm sorry, I can't remember whether it's cut or fill or cut, but obviously the fill would go under 0.5, and the cut would go under that one, which is 0.25. Now that difference column is further along, and you need to fill that in manually. You need to fill those in and those in, and it'll go and give you an answer down the bottom. And basically, I want you to cut and paste that last column into your AutoCAD drawing to get full marks. So how does the marking work for the diploma? It's worth 3 marks, I think. Once again, we'll check that out on the assignment when I log in. At least 1 mark will be dedicated towards you doing these little stick diagrams in Moodle. Now here's the cool thing. That one there is going to be 0, so it's just a straight line. And all you have to write above there is 0 meters squared. The bottom one is also 0 meters squared. Goodness me, 1, 2, 3, 4, 5, 6, 7. I've already done 2. Hold on a minute. Roger's asked us to do this one as part of our assignment, right? BB or whatever it is. So you copy that bit from BB, just that bit. I've now done 3 out of 7. So really, before you start saying, oh, all this extra work, you've only got to draw up this one, this one, this one, and this one. Now, these 1, 2, 3 should be very easy because they're almost the same looking. That shouldn't take you very long. I'm going to draw one of those up for you today. These two are tricky because, as you can see, it goes through the cut and then there's a bit where there's nothing in here, and then it goes, through the fill and then nothing and then through the cut. So you have to project down to make those ones up. They're the tricky one out of it all. You can avoid that. A lot of students put it on the last line and then there. That won't get you full marks. So you've got to work that out yourself. Here's a clue. Why not put that exactly on a contour line when you do your contours? Then you know that height there and that height there. So if it goes through a fill contour and then through a cut contour, then you'll have those two heights there, and you can draw those heights on, and it's very easy to do the cross section from there. So that's how it's all done. I did go over that this morning with today's lecture. So those that weren't there are getting a little bit extra. But technically you are supposed to turn up to all classes. The Prismoidal is there for you to keep, take home, do what you want with it. Alright, sell it, whatever you want, but it is great for future. At the end of your diploma you have to do a thing called project, and you will have to calculate some volumes and some areas and stuff like that. In fact, it's an accumulation of everything you learn at Unitec. So a lot of the stuff that's coming out of my mouth you'll have to use, and you'll have to use Baba, he's teaching fluids, Sam with the geotech, Intan, geology I think. All those different things will be combined, Ingrid with the English, communications, and you'll be doing one big project. So this volumes thing may come in very useful when you get to that stage as well. Okay? And of course in the workforce. Are there any questions on that? What you have to do? You nominate, I don't care where you put these, I want 7 of them, but I have said I want them to go through the cut and the fill at the top and the bottom as well to get a fair representation. It's not perfect because you're starting at 0 and finishing on 0, whereas you probably could put some more through. Technically, the more you do, the more accurate it is. So if you did 20 of them, you'd end up getting a very, very accurate volume. But yours would be very different to someone that's done 7. Alright? I'll point that out on the overhead when I'm demonstrating drawing one of these. I'll point out on the assignment what I'm talking about. The other thing we talked about in today's lecture, which I think I probably should tell you, because I don't want everybody else losing marks, is you have to do a design statement. Number 1, it needs to be on Moodle. Don't send me a Word document or a PDF by email. On Moodle you'll see a text box. Simply copy and paste it into the text box. What is a design statement? Well, a lot of you have just about done it. Some fantastic notes already. First glance of the diploma drawings in this, some people have done up to 15 notes, which is really, really good. Grab those notes, put them into Word. That's a good start. Things like design engineer needs to look at such and such. Environmental engineer needs to look at the trees, blah, blah, blah. But now have a little think about what a design statement is. Well, a design statement starts off by explaining what the job is. Okay, so it's over there somewhere, so you could describe where at Unitec it is. What's the general slope of the land? what's the size of the platform, what is the slope coming down, the batter slopes. Then you could go into something like talking about the zoning, which is residential. Unfortunately, we can see that already going on way down the other end. Then you could start to say things like Unitec is a college of learning, so there's a lot of students around, a lot of traffic around, etc. And you could also point out that there is wetlands. There's an interest with iwi, with the water, and a few other things as well that we've talked about, the trees, etc. The next step is issues. I keep on banging on about them, but I'll say them once more. The water, stopping the siltation getting in, the trees, the pipe underneath, the site access, traffic cones, that sort of thing. Students are a problem as well. Engineering ones particularly, they're going to want to go over and have a look and see what's going on. They're nosy. So you need big fences for students, little fences with mesh for the pookie goats. Mind you, they can fly, but they're pretty dumb. They tend to try and walk everywhere. So stop them getting in. Then you've got the protection of the wetlands and the water, like I said. And then you've got things like dust. Is going to be a big problem in summer. A lot of people simply say, look, why don't we do it when the students are away in summer? Well, there'll be dust everywhere. There'll be dirt everywhere. I don't know if you know much about sites and traffic and all that sort of thing, but if the diggers start going up and down, or the trucks going up and down Carrington Road have got mud on them, and they're spreading mud all the way down Carrington Road, the traffic department will turn up and they'll close the site down. So you'll need to come up with some solutions to all these problems. And I would say a wash down station or something like that would be good for the truck area, to wash the tyres down before they go on the street. Noise control, only doing it through a certain time during the day. Don't do it during semester. And then of course there's the trees and the wildlife and all the rest. So 1, describe the area. 2, come up with some of the issues. 3, come up with some solutions. Not too hard, maybe 100, maybe 300 words, tops. It sounds a lot, I know, to some of you, but it's probably only half a page. I'm sure most of you will probably be able to bang on a bit more than that about it. There is no limit, but I do get sick of reading after a certain amount of time. So yeah, I'll give you a mark out of 2 or 3, whatever it is, for that, and I'll give you a mark out of 2 or 3 for that. So this time round, the drawing isn't all about drawing. It's about kind of taking things from the drawing and putting it into words and putting it into maths. Lastly, with the volume, I'm expecting you to do a compaction factor on it. Compaction factor of 25% and 30%. 30% for the bulking, 25% for the compaction. That, my friends, was explained in the lecture with little Johnny digging a hole in the backyard. It's not quite what it seems. It's not just a straight 5% difference. You will need to apply one of them to the fill and one of them to the cut. Alright, and Mr. Lemming at the back there will not be telling you the answer to that. He knows it anyway. This isn't his first rodeo as such. Okay, I'll log in, I'll demonstrate the cross section, how to draw one at a certain point, just a stick figure, and then I'll let you have the rest of the time to do your assignment. Our student will walk around, anyone put their hands up or come and help. If the problem is too hard, then